Hello everyone. For number 31, we're taking a look at a residual plot. And keep in mind what residuals are. Residuals are basically like how far off was your line of best fit. So if you had a scatter plot and you graphed a line of best fit, the residual tells you the difference between your actual value and really what's like your estimation with the line of best fit. And if we look at the bottom, we're eventually going to be assessing it. Keep in mind that there's two outcomes with residuals. When we graph our residual plot, which looks like a sideways T, the actual graphing process isn't going to be bad. We're just basically plotting values like you would any graph. But we're going to have one of two outcomes. We're either going to have some type of pattern, usually it's something like this, okay, or some kind of random scattered points all over the place. What a pattern tells us is that the original data was nonlinear based off the residual outcome, based off how the residuals fit the line of best fit or how they kind of responded to the line of best fit. Randomness is actually good. That means our line of best fit worked out well because the original data was linear. Obviously, if the original data is close to being linear, a line of best fit is going to fit it, no pun intended, quite well. So let's see what we get. We'll keep that concept in mind. So I'm going to be plotting. You could write like one box equals 1 unit, or you could label your lines here 1, 2, 3, 4, and label your residuals. I'm going to be plotting each set of points kind of like a column. So I'm going to plot 2, 2, 3, 1, 3, negative 1, 4, negative 2, 6, 5, 6, negative 3. Just be careful because these do skip around a little bit. You can see we didn't have a 5 value there. 7, negative 2, 8, negative 1, 9, positive 2, 9, 0, and 10, 3. Okay, so that's what our residual plot looks like. Just to save me the trouble of labeling here, we'll just say one box equals 1 unit. Now I'm going to assess it. So based on what I see visually of my residual plot, what does that tell me about the fit of the line? In other words, what does that tell me about the line of best fit that was hypothetically made here and that we can't see? Based off my residual plot, I notice a pattern. Almost looks like a smiley face or a parabola. Any type of pattern or curve in the data, like we mentioned earlier, is going to be this case, nonlinear. So we'll say the fit of the line is poor or bad, anything like that, since the data is nonlinear. And this is referencing the fact that there was a pattern in the residual. Put little parentheses here. Pattern in residual. Or curve in residual. Pattern. It's not exact, as you see. It's not like literally a parabola, but it kind of looks like one. That's a general pattern compared to like complete randomness. And that would be a full credit response. We have our graph set up correctly, and we've assessed or analyzed the fit of a line. It's not going to work out well because the original data is nonlinear, meaning a line of best fit. If the data is some type of curve, is a straight line going to fit that pretty well? Probably not. And that would be our final answer. Okay, thank you for watching.